Talk about Chapter 11 and Chapter 12. So in Chapter 11 is when we first learned what a confidence interval is, which is creating an interval that you are some number % confident that you've captured the true mean, proportion, or difference. The formula for a confidence interval is x bar plus or minus z star times the standard deviation over the square root of n, and n is your sample size. So for the confidence interval, we have a 4-step process. Number 1, state the name of the of the interval. Number 2, state your conditions. The conditions for a confidence interval is, was an SRS taken? Is it normal or n is greater than or equal to 15? And is it independent or n, the population, is greater than or equal to 10n, the sample size? Step 3, you state your formula, which is x bar plus or minus z star times the standard deviation or the square root of n. And you can either solve plugging into this formula, or you can run a confidence interval on your calculator. And then step 4, you're going to get your interval and you make your conclusion, which is the true mean falls in the interval of whatever you calculated. So a test of significance is a test done to determine the p-value, which is a probability, assuming the null hypothesis is true, that the test statistic would take on a value as extreme or more extreme than actually observed. In terms of tests of significance, we have the null hypothesis and then the alternative hypothesis. So the null is the statement being tested, and the alternative hypothesis is the claim we are trying to find evidence for. The formula for a test statistic is z equals x bar minus mu over the standard deviation divided by the square root of n. And once you find this, you run your test, you have a p-value. If the p-value is less than your significance value, then you reject the null hypothesis. But if it's greater, then you fail to reject the null hypothesis. So for a test of significance, there's also a 4-step process. So for step 1, you state the name. Step 2, you state the conditions, which are the same as a confidence interval. And then step 3, you state your formula, z equals x bar minus mu over the standard deviation divided by the square root of n. Then you draw your curve, and you can either solve this by hand or use your calculator and run a z-test, and you're going to get a z-value and a p-value. So as I said before, if the p-value is greater than your significance level, you fail to reject the null hypothesis, and if the p-value is less than the significance level, you reject the null hypothesis. The second part of Chapter 11 is power and error. Power is a probability that the test will reject your null hypothesis in favor of the alternative hypothesis when it should, basically meaning the null hypothesis is not true. So how you solve for power is, for your first step, you're going to state HO, HA, alpha, n, and standard deviation, and your specific alternative. And step 2, you should find the values of x bar that will lead you to reject HO. And how you do this is you use the formula z equals x bar minus mu over the standard deviation divided by the square root of n. You plug in all the information and you solve for x bar. Or you can use a calculator and solve using NB norm. And that would be step 2. And then step 3 is calculating the power of observing x bar values when the specific alternative is true. And this can be done by using the calculator by using normal CDF. A power of 80% or higher is ideal. Next is error. So type 1 error is rejecting incorrectly, rejecting the null hypothesis, but it was true. Alpha equals a probability of the type 1 error occurring. Then there's also the type 2 error. Fail to reject incorrectly, so you're failing to reject the null hypothesis, but it was false. And B equals the probability of a type 1 error occurring.
So now moving on to Chapter 12, which is significance tests in practice. We will be focusing on 3 major tests here. So one being the one sample t-test for population mean, the second being one sample matched pair t-test for population mean difference, and the third is the one proportion z-test for population proportion. So 12.1 is the test about a population mean. So here are the first 2 tests, one sample t-statistic with your null hypothesis posted below, and your one sample matched pair t-test with, once again, your null hypothesis is below. Both of these have the same conditions, making sure that your data is from an SRS, making sure that it is normal or that n is greater than or equal to 30, and making sure that the observations are independent, or n is greater than or equal to 10n. Now moving on to step 3 of the 4-step process that you learned in chapter 11. Both formulas are given on the right side of the slide. So the first one being the statistic formula, with n minus 1 being your degrees of freedom. This tells us how far x bar is from mu in your standard deviation units. And then the formula below that is your interval formula. So basically, you are using these when, for your one sample t-test, you have your population standard deviation unknown, so you're using S, and you're using this sample mean, which is x bar, to infer about the population mean mu. And now moving on to the matched pair t-test, it's important to note that the null hypothesis is different for this. But this test is different because you still are given one sample, but each individual has 2 measurements. For example, you have like a before and after for one individual. So in your calculator, when this comes through, you need to have L1 and L2 all filled in L3, you can do like L2 minus L1. And when solving, you are only using the numbers in L3. And for both of these tests put together, your p-value calculation is done using TCDF on your calculator. Now moving on to 12.2, the 1 proportion z-test. Your null hypothesis is posted below, again with your test statistic and your interval formulas right below that. So for this, the assumptions, or the conditions, are a little different. Your data still needs to be from an SRS, but your normality is found differently. So n times p hat is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10. And it must be independent, or n is greater than or equal to 10n. You are using this test when you have, again, one sample, and you use the sample proportion p hat to infer about the population proportion p. And when solving for the p-value for this calculation, you will be using normal CDF instead of TCDF, which you used for the last 2 tests. So again, you are using these tests using your 4-step process that you learned in chapter 11.